Hello! In this video, we're going to prove the following theorem. Suppose A, B, and C are sets. Then A set minus B set minus C is a subset of A set minus B or C. Okay, so let's suppose that A, B, and C are sets. And now we want to prove that everything in this set is also in this set. So give me an arbitrary element of this set. I'll call it X. Okay, so what does this mean? Well, really, it means that X is an element of A, and X is not an element of B set minus C. Okay, now I would like to make a deal out of what this means, because it's important. Now, we know what it means for X to be an element of B set minus C. Right? All this means is that X is an element of B and X is not an element of C. Okay, so then what does it mean for X to not be an element of B set minus C? Well, it means that this is not true. But really, we can use De Morgan's laws to re-express this, right? If we distribute the negation through the parentheses, we have that this is equivalent to saying X is not an element of B, or X is an element of C. Right? So to say that X is not an element of B set minus C is the same thing as saying either X is not an element of B, or X is an element of C. So really, we can apply De Morgan's laws to this and just simply say that this means that either X is not an element of B or X is an element of C. Okay, so what we gotta do is we're going to prove in either case we have that X is an element of this set. So let's start with the case that X is not an element of B. So in the case where X is not an element of B, well, we know that X is an element of A and X is not an element of B. So X must be an element of A set minus B. And since X is an element of A set minus B, clearly that means X is an element of A set minus B or C. And so that completes case one. Now let's consider the other case where X is an element of C. Well, wait a minute. Because X is an element of C, clearly X is an element of A set minus B or C. And so in either case, we have shown that X must be an element of A set minus B or C. So we can conclude that X is an element of A set minus B or C. So really, we start with an arbitrary element of this set, and we showed that same element must also be in this set. Therefore, everything in this set is also in this set. Exactly what we wanted to prove. And so this completes the proof. And so yeah, that's pretty much the idea of how you could prove a theorem like this. So yeah, that's pretty much it for this video.